Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem print all the nodes that do not have a sibling. Now, this problem is based on trees and it has been asked in a lot of companies. So basically, we have to print all nodes that do not have a sibling. So we'll be given a binary tree which will be consisting of n nodes and we have to find all the nodes that do not have any sibling. So you need to return a list of integers containing all the nodes that do not have a sibling in the sorted order. So whatever nodes will be there which do not have a sibling, we have to print them in the sorted order in a list. Okay. Now two nodes are called sibling if their parent is same and they are on the same level. So let's take the sample example. Let's say if we have got 37 first of all. Okay. After 37 we have got what? We have got 20 and then 30. Then 113. Okay, so if these are the nodes, so obviously for the root node of the tree there will be no sibling. Okay, you need to understand one thing, that the root node of the tree will not have any parent, right? So that is why it will never be considered inside the answer. So you'll always start considering from the left child of the root and the right child of the root, and you'll go below them as well. Okay, so when you're going to start off, so you can see that initially you'll be at 37, that is the root, but you're not going to consider it. Then after this, what you will check is, with respect to 37, you will check, does the left exist? Yes. With respect to 37, the left exists, but does the right child exist? No, the right child is basically null. So this indicates that 20 is a sibling, like 20 is a node which does not have a sibling, because if the node 30 is there and for 30 the left child exists, which is 20, and the right child does not exist. So this means 20 is a node which does not have a sibling, because 20's parent is what? 37. So 37 is there and 37 has got only one child because the right child is null. Correct. So that is why what we can check is that if we are at a particular current root node and suppose its left child is existing, right is not existing, then we'll say that the left child will be a single element. It will not have any sibling. Okay, so we can write 20 in our answer. We can put it. Then after this, with respect to 20, we will check. So when I check for 20, so its left is 113 and the right of 20 is what? The right of 20 is basically null. So you can see here again, guys, that when you are at the node 20, so its left is what? Its left node, you can see it exists and the right does not exist. So again, you can say that the node 113 that is there, that is 20's left child, it is a single node. It does not have any sibling, right? So then we can put 113 as the answer as well, and you can see final answer will be 20 and 113 only, right? Because there are only two nodes that do not have a sibling, and you can see that is the answer. Obviously here the answer looks sorted, but you will be returning the list in the sorted format because it is not always necessary that the answers will become sorted when you are pushing them. Okay, then suppose that if we take some other tree, let's say if I will take a tree like 1, then after that I have got 2 here, then after that I have got 3 here, then after that I have got 4 here, then I have got 5 here. Okay, let's say I've got the node 6 here, and then I've got the node 7 here. Okay, suppose this is the data that I have got. So when I'll be starting from the root node, so I'll check for 1, does the left exist? Yes. Does the right exist? Yes. Since both the left and right are existing, so neither 2 nor 3 will be put inside the answer, because 2 and 3 both have got siblings, because 2 sibling is 3, 3 sibling is 2. Then you'll call both on the left and the right. If both left and right child are existing, so you'll call on both. Now what happens is you call for this particular element 2. So when you are at the element 2, so you'll check, does the left child exist? Yes, it does exist. Does the right child exist for 2? No, it is null. So this means that the left child is a single element. It does not have any sibling. So that is why you will put 6 inside your answer. Then after that, since the left only exists, so you'll go to the left child. Now when you go to 6, so you check, does there exist a left child? No, it does not. Does there exist a right child? Yes. So the right child is existing, whereas the left child is not existing. So since the left child is not existing and right child exists, so 7 can be considered as a node which does not have a sibling. So you can put 7 inside the answer here, right? Now once you are done with this, so you'll go back up, then you'll go back, then you'll go back. Now with respect to 1, you will do what? You will call on the right. So when you call for 3, because with respect to 1, both the left and right child were existing. So one time you called on the left, when you came back from the left, so now you'll call on the right. So when you call for 3, so with respect to 3, its left child exists, whereas the right child is null. So since the left child is existing, so you'll put it in the answer. So you'll put 4 inside the answer. Okay, then after this what will happen is you will go to the left child, that is 4, and 4 does not have a left child, 4 has got a right child. So since 4 has got a right child 5, so you will put it inside your answer here. Okay, because 5 will be considered as a single node which does not have a sibling. Okay, so you can say here that after this we will sort the array, and the answer will be 4, then 5, then 6, and then 7. And that is how we'll be returning this particular answer in the sorted format, because you can see that the nodes 6, 7, 4 and 5, these are the 4 nodes that are there in this particular given tree which do not have a sibling. Okay, so I hope that you have understood the idea for this problem. Now let us try and implement it in terms of code as well. So what I'll be doing here is I'll be using a recursive way to traverse the tree. So what we can do here is, first of all, I need to store the answer. So I'll declare a vector int answer. Okay, then we will do what? We will call the recursive function, and let's say we are passing the node here. Okay, so let's write it as root. That will be better for us to understand. Okay, so let's write this as the root. Okay, so I'll be passing the root node right here, and then after that I'll pass answer here. Right now, once I will get my answer list in return, so I need to do what? I need to sort this list, because they are asking me to return the nodes which do not have a sibling in the sorted order. So what I will do is I'll write answer dot sort answer dot begin comma what answer dot end. So I'll be sorting it from the beginning till the end in ascending order, and then after that we can simply do what? We can simply return our answer. And now let us complete this recursive function. So what we will do is we can write a void recursive function, and let's say we have the node star root. So we have the root node of the tree. Okay, and then after that we also have got what? We also have got vector int ampersand answer here. Right, now what will happen is, suppose that if I am at a particular node whose value is null. So if I am at a particular node which is null, so in that case I can simply return from there. Otherwise what I need to check? Otherwise I will check that for the current root node that I am at, if its left exists. Suppose that the left child is what? It is not null. Suppose that the left child is not null and the right child is null. Okay, for this particular current root node, if its left is not null and the right child is null. So if the left is not null and the right is null, so this basically indicates that the left child that is there, it does not have a sibling. So we need to push it in our answer. So we will do what? We will simply do answer dot push back, and you can say that we will push back roots left child's data. Okay, and then since only the left child exists, so I do not need to call on the call the recursion on the right. I'll only call it on the left. So I'll do what? I'll call for the roots left here. Okay, and I'll also pass this answer array. Okay, now otherwise I also need to check that, suppose that if the current root that I am at, if its right child is not equal to null, if the right child is not null and the current root that I am at, okay, its left child is equal to null. So suppose that if the right child is not null and the left child is null, so in that case what you will do is you will simply push back what? You're going to simply push back the roots right, okay, child, and its data you can push simply, and then you can call on the recursion on the right. So you'll call for a recursion of roots right child, and then you will pass this answer. Okay, because if the left child exists and the right does not exist, then in that case what you will do is you will say that the left child of the current root is a element which is not having sibling. So you will push it in the answer, and then you will call for the left child. Okay, for the recursion. Then otherwise, if the right child is not null and the left child is null, then you will push back your roots data. Okay, and then after that you will call the recursion roots right data you will push, and then you will call the recursion on the roots right child. Otherwise, if suppose that the left and right both are not null, if both exist, then you can simply call the recursion for what? You can simply call the recursion for the roots left child, and you can pass this answer array, and you can simply call the recursion for the roots right child, and you can pass the answer array. Okay, this is how it will be done. Let us try and compile this code to check if it is working fine on the samples or not. So you can see it is working fine on the samples. Let's try and submit this code to check if the code is getting accepted. I hope it should get accepted now. Okay, so it is giving me a wrong answer because it says that my code's output is not. Okay, suppose there is no sibling. So I guess in this case we have a edge case that is written down here. Okay, so if all the nodes have a sibling, so you have to return the list with only one element minus one. So we need to tackle one case here, that suppose that after your recursion is over. So what happens is, after your recursion is over, you need to tackle one more condition, that if the answer dot size is 0. So if there is no node which if there is no node there which is having any sibling, like if there is no node which does not have any sibling, right? So if all the nodes have a sibling, then answer will be empty. So what you will do is inside the answer you will push back -1, indicating that there is no node which is not having any sibling. Okay, so that is why you will simply return the answer with -1. If you are having empty list in the end, so you have to return the list with the value as -1. Now let's submit it. It will get accepted on all the test cases. So let's check. Yeah, you can see that it is getting accepted. And talking about the time and the space complexity, so if you look at the time complexity for my code, so we are iterating through each node exactly once, so the time complexity would be order of n, and the space complexity would be how much? We are storing n nodes in the worst case in the answer array, as well as we are applying recursion, so the space complexity will be order of n. I hope that you have understood this problem clearly, and it has been asked in a lot of companies as well. So make sure to comment down understood or +1 in the chat, and thank you for watching this video. Keep coding, guys.